Thanks for joining me right after lunch. And again, sorry for a 5 minutes delay, I think. Let's see if I have to make it up during the talk or solve it in any other way. My name is Erwin de Gier. I'm a software architect at Trifork Amsterdam, and I'm currently working on a project called Blocks, which is a cryptocurrency trading platform, and we run on Google Kubernetes engine, which is the hosted version of Kubernetes provided by Google. So out of you in the room, who already uses Kubernetes, please? Almost the whole room. So if I ask about Helm, will it be the same amount? Okay, so we can do the talk together. Let's go back around 15 years ago. When I started out, one of my first software development projects, our main project deliverable was an EAR file. We basically run on a WebSphere, and I think if I look around the room, people recognize this name. Maybe we get IBM JBoss in a few months as well. After WebSphere, we moved to deploying WAR files on Tomcat and jar files, of course, with Spring Boot, Vertex. But then with the containers, this changed a little bit. We were not delivering our Java artifacts anymore, but we were delivering Docker images. And now on the project we started in January, basically the stuff we deliver the most is YAML. So I think 80% of the files, the stuff we write is YAML file, YAML file, YAML file. So of course this has to do because we run on Kubernetes. And we deploy our Docker containers inside Kubernetes, but Kubernetes needs a lot of configuration. It's just not just deploying a Docker image and letting it run, but there's a lot of stuff that needs to be described around it in order to function properly. Of course, it does a lot of stuff for you. The scheduling of images, instances on pods, and networking, making sure that the amount of replicas is correct. So since you already know Kubernetes, we can maybe do this one a little quicker than I normally do. But this is basically an overview of stuff you deploy on Kubernetes when you deploy an application. So all the dots you can consider container instances or pods. Pods is basically the scheduling unit that you have. So basically one app instance is more or less related to a pod. And then, of course, you need to have service definitions to expose your pods so they are able to talk to each other, probably ingresses because you want traffic into your cluster. You have to define how many replicas your deployment has, so the amount of instances. You need to provide scheduling information, but also stuff like configuration. So if you, for instance, would like to deploy something like a SonarQube, it's one of the first things we deployed in Kubernetes because we wanted to do code quality monitoring and host Kubernetes SonarQube ourselves. So of course you need a SonarQube container instance, but you probably need a database as well because you want to store your analysis results. If you have a database, you need something like a persistence volume claim. That's basically a volume amount where the database can store its data. But these things need to talk to each other, so you need the services. You probably have some kind of secret as well, because you have a password to go into the database. You need to access Sonar running inside Kubernetes, so you have an ingress. So for us, it's something like blocks.tooling.com/sonar, and probably a property file where you store the configuration. So it looks something like this: deployment configuration. You probably recognize this kind of definition. But you also need pod configurations and service configurations. So that's a lot of stuff to manage. So one of the first things we were looking into is how can we manage all these Kubernetes deployments in an efficient way. And one of the tools that came up in January was Helm. And Helm is basically a package manager for Kubernetes deployments. So you can compare it a little bit with something like Maven for Java projects or NPM for JavaScript. You can package your artifacts in a way that it's able to version, but also to share it, but also to define stuff like dependencies. So very similar to a Maven or NPM or Gradle. And the goal here is to be able to manage complex Kubernetes deployments. And the SonarQube one I showed, it's a pretty simple deployment, but it already involves lots of moving parts. So let's have a look at how this looks if we want to install SonarQube in Kubernetes with Helm. So basically what I have is I have Docker for Desktop running. And as you might know, Docker for Desktop has Kubernetes inside, optionally. So first let's check if I'm connected to the correct Kubernetes instance. This is somewhat important because it's really easy to deploy stuff to the wrong environment, as we have noticed, but Docker for Desktop sounds good. If I get my namespace overview, you will see the default stuff you get if you run Kubernetes in the Docker app, so public kube system. And now, if you want to install SonarQube, basically what you can do is say Helm install, and then the name of the stuff you want to install. In this case, it's called stable SonarQube because it's the stable release of the SonarQube package. And I'm installing it in a separate namespace called SonarQube. So if you install this, then basically you get an output from Helm saying the stuff you have installed. So you recognize the persistent volume claim, the service, the deployment, and the pods and the secrets. Now, if we have a look at what's actually being deployed, then we have our two pods for Postgres and for SonarQube. And of course, it doesn't come out of thin air, this deployment. Someone has to write these deployment files. And the nice thing about Helm is that they basically have an app store for Kubernetes applications. So an Helm package is called a chart. So this Git repository is called Helm charts. And these are all the definitions of the charts which are available on the public Helm Kubernetes app store, if you want to call it like that. So there's something like a Bitcoin daemon here, which we tried as well for our integrations with the blockchain. There is our SonarQube, of course. So if you look inside this folder, there's some configuration. So for instance, there's a definition of the chart. Is this readable in the back, by the way? I wasn't able to test the font size. Yeah, readable? Good. Which has a name and a version. And it has templates, which are basically template files for the definition. So we have a look, more detailed look in a moment. In the meantime, this has started up. So that's nice. So if I now have a look at what kind of services were deployed, then there's one for the database, of course, and there's also one for the SonarQube web front end. And it actually exposes on port 9000, which we are used to. So this now should show up Sonar. So this is basically one line to install SonarQube on your Kubernetes cluster. So let me now reset it. So Helm is quite of a technical tool, so I think the best way to go through this process is to do it ourselves, but you don't have to get your laptops out now, but the talk is set up in a way that you can probably follow along if you want to replicate this stuff. Basically, Helm consists of three components. The one that you see the most is the CLI. It's the one I used just now in my terminal. A command line interface that connects to something running in the Kubernetes cluster, which is called a tiller. A tiller is a daemon. You have to install it once, and then it runs inside your cluster in a namespace. And that one interacts with Kubernetes to install your applications. And the nice thing of this tiller is that it also keeps state. So say, for instance, normally we install our stuff through our CI system. We use GitLab CI, and that runs our build, and it installs stuff for us in the Kubernetes cluster. And if I want to interact with it from my own machine, I can just run my Helm CLI against the tiller in the cluster, and I get the same state. So you don't have the state locally on your machine. The state is kept in your Kubernetes cluster. And this is something where there's, for instance, a difference with Terraform. You can do similar stuff with Terraform, but that keeps state locally. And the third component is the chart repository. And I already showed you the public one. So that's like comparable to a Maven Central or a Docker Hub, where everyone can share the chart definitions, but you can also run your own repository. We are actually running our own repository for all the charts we make. And you can also use local files, so files on your file system, and that's something we're going to do just now. Let's have a look at another simple service. So basically this service has a front end consisting of PHP web servers. There's a Redis master and 2 Redis slaves. And this is, you might recognize this as a guestbook example, which is often used for Kubernetes tutorials. So if we have a look at how part of a YAML Kubernetes manifest file would look without Helm, it will be something like this. So this is the deployment configuration, and stuff that is interesting, for instance, is a reference to the Docker image you actually want to deploy. Because the files are just the YAML files, of course, and you have to point to a Docker image that's somewhere deployed inside the Docker registry. And for me, when I saw this the first time, I was like, okay, this is nice, but I don't want to have my image name and the tag and the version inside this YAML file, because my versions are dynamic. They are a result of our build. We use our git commit hash as a version number. So I don't want to have it here. So you want to extract this out. And that's actually exactly how Helm works. Basically, if you have to say it in a very short sentence, you say, well, Helm is like just a template engine for Kubernetes manifest files. So instead of having the hard-coded values, for instance, there's a image and there's a template variable, in this case, values.frontend.image, and there's one for the container port as well. So, of course, you have to specify the values to actually generate the Kubernetes manifest file. So if you have a look at what's in a chart package, then this is a kind of a minimal version. So we have 2 templates. The templates is the file I just showed, so the Kubernetes manifest file, but then the templated version. There's a chart file that is a description of the chart, so metadata, name, version. And you have your values file, and the values file contains the actual values of the stuff that you want to put into the manifest files. So, if I'm correct, then my cluster is reset, so I can now start from the beginning. So basically, where I am now is I cloned the Git repository, and that contains the chart I just showed on my slide. So we have the chart YAML, the templates, and the values. And inside the templates, we have guestbook deployments and the guestbook service. Let's have a look at namespaces. Okay, the first thing that we have to do is we have to install the tiller. And Helm has a command, helm init, and it will check the cluster if the tiller is there, and if it's not there, it installs the tiller. And you already get a security warning, which is a good thing, because by default, the way the tiller is installed, it has access to everything. So it can also do cross-namespace interactions, like cross-namespace deployments or removal. So it's something I will touch upon later, but using Helm for production, you have to set it up differently than the default way, but this is a nice way of having a quick start. So if we now have a look at the kube system namespace, and we ask which pods are available, right at the bottom you can see that the tiller is deployed there. So it's just running inside Kubernetes as a pod as well. So I'm now installing our whole guestbook application from the file on my local system. So the first thing we have to give is a sensible name, otherwise you get a generated name. With the SonarQube one, we didn't use the release afterwards, but the release name, you might want to give it something that's recognizable. Of course, you specify the namespace, and I say take the chart from the current folder. Now, Helm responds with all the stuff it's going to install, so we should now have a new namespace. So we now have the Helm guestbook namespace, so that's correct. So let's see what's running there. Everything's ready already, so everything's deployed. when we look at the services, we have a couple of services. We have a front end, a Redis master, and a Redis slave. And this one exposes a port, so we can now check if it's actually running. So the sonar should be down. That's correct. And this one is, some might recognize this one. And let's see if it works. It works. That's always nice when the demo works. Okay, so we now have one deployment, so we can ask Helm, because it has the state, what's the history of this deployment? And of course, we only have one revision. We just installed it, 10 minutes past 2. You get the chart name, and you get some kind of description about that revision. Now, something that you often want to do is install a new version of your application. So Helm has an upgrade command. And basically what we do here, hit enter in the meantime, is we provide a different value for one of the things that was in our deployment description. So in our deployment description, we had a reference to a 1.0 version of an image. And what you now want to do is say, okay, I want to keep the deployment the same, except for the image, because you have built a new image of your application, you have deployed it inside a Docker registry, you have tagged it with 1.1, and now you can tell Helm with one command line parameter to override the value and say, okay, let's install version 1.1. And Helm says, well, everything is okay, it was created, so if you now have a look at the history, you have 2 revisions. The first one had status deployed, it's now superseded by a second revision, and that version is deployed. So everything should be working okay. Right now, everything works, so let's have a look at the pods. So what we now see is that Kubernetes tried to deploy a new version of our application, but apparently the image cannot be found. So the image we specified, the 1.1 version, is not available. I don't know what happened. I want to fix this fast. So what you can do is do a rollback. So Helm has a rollback command where you say, okay, the name of the release. Please roll back my deployment to revision 1. So you now see Helm is going to do a rollback. So I have a look at the history. So now you see you have 2 superseded versions, and this last one was a rollback of this one to the first one. So if we now go back to the Kubernetes overview, I hope everything will be fine. All my pods are running, all my pods are ready again, so order has been restored. So I showed the public chart repository, and I showed you can use local files. The thing that's actually present in the chart repository is not an exploded version of those files, but it's a tar package. So Helm has a command to package up all the files, and then you can upload them to a running repository. You can also run a local repository, so you can do a Helm serve, and then it will all basically spin up a HTTP server. And the repository is really simple. It's a HTTP server with an index YAML and the package files. So there's nothing really complex. So I think ours runs somewhere inside the Google storage, where we manage our own charts. I showed you this, the App Store. So if you use the chart repository to share the charts, because this is something that we do in our team, similar to, for instance, Nexus. You create an artifact, you upload the jar files into Nexus, and then other teams can use the same jar files, or you can use shared libraries. With Helm, we can do exactly the same thing. So something that we use inside our cluster is Exonic Server, which is basically an event store and a communication hub. But there is no Helm chart available for that one. There also was not a Docker image available for that one, so we created our own Helm charts, our own Docker images. And we have multiple clusters running that, the Axon products. and we want to reuse those files. So we put them in our chart repository, and now we can just install them from the repository. But of course, a lot of configuration in there are sensible defaults, but it's not always what you want. I think something like a database password, you probably want to change that for your own chart. You don't want to use the one that's in the public repository or even in your private repository. And there might be ingresses, persistence value claims, maybe even resource claims, all kinds of stuff that you want to customize yourself, but you still want to do the sharing. So there's a chart values YAML file which contains the defaults, but you can also supply your own YAML with the -f command, and then you can say, okay, this values file is a specific one for my production environment, and you only have to put the stuff in there that you want to override. The third option I showed, you can also put it in command line, so overriding specific values. And for instance, if I want to run SonarQube on 9001 instead of 9000, I could do set service external port 9001, and then it will override the 9000 value, and I can use it on the specific port. And the last option is to use the set file, and you can just pass a whole file on the command line. So that's about configuration. Now, you know that if you deploy stuff on Kubernetes, it's usually consists of more than one thing. So for instance, for our SonarQube, we want to use a database. And the nice thing about Helm is similar to Maven, you can specify dependencies between charts. So this requirements YAML file, the top one, is actually part of the SonarQube chart. And it defines both a Postgres and a MySQL dependency and a version number. And the nice thing about this is you can use conditions to specify which dependencies you want to load. So you can have a whole complex tree of dependencies, and then based on what kind of deployment you do, you can say, okay, enable Postgres.enabled. So you put Postgres.enabled is true in the values file or on the command line, and then it will install that one, otherwise it will pick the other one. And those requirements YAML file directly correlate with the chart descriptions of the dependency of the library you're dependent on. So if you go to the Helm chart repository, this is the one from SonarQube. If you go to Postgres, then you will actually find a chart YAML file with this information. So you can reference from one and to the other. And this is just one dependency, or actually two, but you can make whole trees out of this by using this mechanism to have really, really complex applications with different moving parts that can be deployed as part of one release. So how do we use Helm? We basically use GitLab CI. And in our builds, of course, we built our Java jar files, Spring Boot jar files. And then we create a Docker registry. We push the image there. And if the chart changes for this deployment, we built a chart and we upload it to a chart repository. But that's something that it doesn't happen a lot, because basically after a few iterations, you know how your application looks, and the only thing that you change is the values, and you don't change the chart itself anymore. And then we use Helm from our GitLab CI to upgrade our app inside Kubernetes. And the nice thing for this is that I think we run about, let's say, 15 services. And they all use the same chart as the service definition. And we only have very minor differences between our deployments where we use the specific values file to override. So basically, this is for us a really nice way to share our Kubernetes file, manifest files, but still be flexible in what's in there. And this is for the stuff we built ourselves. But we also have a similar process running in a separate GitLab CI for all our infrastructure-related things. So, for instance, I showed SonarQube is something we have running, but we also use Keycloak inside and Nexus. And we use a similar approach for this, except that for a lot of the standard components, we don't upload the charts ourselves, because we just use a chart from the chart repository. So you could do dry runs as well. So similar to kubectl apply, you can ask Helm, what happens if I deploy this version of my chart? You just specify dry run and debug, and Helm will actually print a state that will be your state after you upgrade your Helm commands. There's something that allows you to create your own charts by using starters. So you can create an empty chart, much like Maven, but Maven with the generate archetype, it also allows you to generate some kind of template. They have a similar function, which is called a starter. I showed chart versioning. There's also an ability to sign your charts, and this is a nice option if you share your charts in a different environment, is you can generate an integrity key hash with your chart, and then on the install or on the upgrade command, you can say to Helm, please verify the integrity of this chart. So because you're deploying stuff inside production clusters, you might want to be 100% sure that the thing you deploy doesn't contain anything that shouldn't be there. So this allows you to check that against a known value. I showed conditions already for specifying dependency. You can also have a more generic approach that is called tags. So you can have a list of tags, for instance, front end. It could be a tag, and then if you have front-end tag enabled, then all the dependencies with that tag will be deployed. And finally, one that is interesting is, because I had a discussion yesterday with someone, and he said, we're doing infrastructure as code, but we don't test. So they put out code without testing anything, basically. And of course, we have a similar situation. Fortunately, for stuff we deploy inside Kubernetes, Helm provides a way to test our release, and what it actually does is it deploys something inside Kubernetes, so a separate pod, and for instance, a test could be as simple as do a curl to some kind of URL, and if you get the 200 status code back, then the test is okay, and if you don't get it at 200, then your test fails. So this is a mechanism that allows you to automate the test, and then basically if a test fails, you could say, okay, if the test fails, please roll back to a different revision or something like this, or at least have an alert or monitoring. Because if you paid attention during the demo, my upgrade failed, but Helm was happy. It just said, deployed, happy helming. So there's no direct relation between a Helm deployment and the result of that deployment. The deployment can still fail, and Helm doesn't know about this, and it doesn't notify about this. So the test feature could be a way around this. I mentioned the tiller warning. Tiller runs in privilege mode, so basically it can do a lot. It's allowed to access a lot of all the namespaces, basically. You can install and remove stuff. There's an integration with row-based access control. And basically that's how we run Helm. So we create a service account, and then we specify which restrictions there are, or basically which access that service account has. For instance, it's really important to think about restricting namespaces if you use namespaces as logical separation in your cluster. I assume that production is usually a separate cluster, but for instance, we have a tooling cluster next to the cluster, or tooling namespace next to the namespace where our application runs. And you might want to have different Helm tillers and different service accounts associated with them. So instead of the plain Helm init, you can do a Helm init with a service account, and that way you can restrict the stuff that Helm does. And the next one is more of a question to you. When I started out in January, we basically looked at Helm and Terraform, because Terraform has a Kubernetes provider plugin. Big downside of Terraform back then was that it was not really up to speed with the API version. So every time there was a new API version for Kubernetes released with new features, then Terraform was behind. Initially, I thought this is nice because we use Terraform to provision our clusters on Google Cloud. So it would be nice to have one tool, but in the end, Helm was a much better fit. But in the meantime, I discovered a whole lot of different alternatives and also different alternatives about how the problem is approached. So for instance, Helm is basically templating engine, so it's very close to the stuff you would do with kube control. There's something that's called JSON templates. It's also templating language, but it's rather different from the stuff that Helm uses. I found KSonnet and Capitan. You also have declarative approaches, which is pretty nice, I think, if you're more from a developer's perspective. I mentioned Terraform, but there's also Customize. So instead of having templates in your YAML file, you actually declare the kind of resources you want with the DSL. I know people say, well, we don't interact with our Kubernetes on this level. We use service mesh approach for managing. So Istio was named as an alternative. And there's a whole lot of alternatives that integrate more on a Git level. So basically, the approach you would take there is you commit your code in a Git repository, and then there's a tool that builds it for the specific deployment, and then it gets rolled out to Kubernetes. So this is something that I think the first version of OpenShift I used this. On Cloud Foundry, I think you have a similar approach. So the whole part of building your own Docker image and uploading it to a repository and specifying your own configuration is taken out of the equation and basically do it for you. So is there anyone in the room that has something to add to this? They use a different approach to deployment? Or one I missed? That's good.
With the CRD operator in Kubernetes.
Sorry?
The CRD operator in Kubernetes that can function as a logical parse that can deploy. So this is something that we examine.
Okay.
Because we want to add some logic also in the deployment itself.
Okay, I haven't looked into that one. It might be interesting after the talk to have a more closer look, because I noticed that Kubernetes is kind of hot, of course. A lot of people use it now. A year ago, it was a little bit less, but there's a lot of tools around Kubernetes popping up. And every time I do this talk, it's like, oh yeah, I have this one, I have this one. So this slide will grow and grow, I hope. And maybe we move away from Helm in a year. For us, I think Helm is a very good fit. It allows us to manage complex deployments, and especially stuff around versioning and updating the apps. Rollback was something that I initially thought we would use a lot, but we actually never used rollback except in the demo I just did. I had whole thoughts around you do a deployment and then maybe you do some health checks and then your script can detect whether the deployment is correct and you might have to do a rollback. But actually on the Kubernetes level, there's already so much that prevents you from deploying something that doesn't work. If you have your health checks properly configured, then Kubernetes can just detect whether the pod is healthy. And if it's not healthy, it's never being part of the deployment anymore. And you just stick with your old version. But maybe in the future, we will have more complex deployments that it's harder to detect the health from just a health endpoint. But rollback is not something that's currently part of our pipeline. And finally, I like that it's now easy to share our Helm configuration. And also, for instance, we had to make a decision about how to do user management, login, registration, and we finally chose Keycloak. And then we thought, okay, but then we have to manage Keycloak ourselves because there's not a hosted Keycloak, but we just did Helm install stable Keycloak and we had Keycloak running. So for me, that's a really, really powerful feature of using Helm for stuff that's readily available.
Thanks a lot. Thanks a lot for the talk.
Thank you.
Very interesting.